Got one. Spider!
Don't scream, Katie. You might shatter the glasses.
I won't shatter the glass. That's just a myth.
No, it isn't.
Yeah, it is.
No, it's not.
Well, let's go find out.
Yeah.
Mythbusters!
Can sound really shatter glass?
That's our testable question.
We think the glass will shatter if the correct resonant frequency is produced at the correct volume.
The resonant frequency is the natural pitch that it makes on its own.
We believe this because according to research, when the correct pitch is produced at the correct volume, the glass will vibrate so much that it will cause the glass to shatter. The glass will vibrate because according to research, each glass naturally vibrates at a certain pitch, also known as the resonant frequency. Research suggests that if we can produce the sound at the exact same pitch as the resonant frequency, that it will increase the vibrations of the glass until it cracks. First step that we're going to do to find the resonant frequencies is we're going to dip our finger in water, take the glass, and rub your finger around the glass until you hear a pitch. That pitch will be its resonant frequency.
While the pitch is playing, we're going to use an electric tuner to figure out what note it makes. Then, we're going to type the note into the tone generator.
Now, with the note typed into the tone generator, you're going to place the glass near the amplifier so that the glass will get the maximum volume. Then, once the glass is next to the amplifier, you're going to play the note at a low volume for 90 seconds. That's 1 minute and 30 seconds.
You're going to do this 3 times at a low volume, 3 times at a medium volume, and not 1, not 2, but 3 times at a high volume. The independent variable is the pitch. The dependent variable is whether or not the glass shatters. Some control variables are the type of glass, the pitch, the distance from the amplifier, and the surface in which the glass is set.
First step is we have to find the resonant frequency of the wine glasses. The resonant frequency is the note at which point the glass shatters. To do that today, we're going to take some water on our fingers and rub it around the glass to make its resonant frequency. To find out what note it is, we're going to use an electric tuner. It tells us what note it is and whether it's sharp or flat. So, we've already done a couple, and we've done 6 so far. And so far, the most common note has been between D and D sharp on the 3rd octave on the piano. This note we expect is going to be from D to the middle of D and D sharp or D sharp. But since no glasses are the same, we don't know. So I'm going to take some water. I'm going to try and make a note. The violin tuner, or the electric tuner, tells me that that note is between D and D sharp. So what we're going to do is we're going to take the piece of masking tape, write D through D sharp, octave 3. Now the octaves are numbered from the middle octave, like the main octave on the piano, and up. So this is 3 octaves up from middle C. We don't want to affect the glass in any way. We're not going to actually put it on the glass itself. We're going to put it over the place on the box where the glass is. Now once we're done with that glass, we're going to put it back in its place. And I only take 1 glass out at a time so I don't get confused. Well, goodbye while we finish the rest of the resonant frequency for the glasses.
Does sound really make glass shatter? Well, we're finding that out right now. But first, let's learn a bit more about the equipment. First, we have a tone generator. This tone generator finds the right tone for each glass and its shattering point. This will make the glass shatter with the amplifier, which makes bigger vibrations. Also, we found the tone with some water by rubbing it on. To mark our results, we have a trial table. We're testing the volume. That's our independent variable. 0 is the lowest, 7 is the highest. So low is 2/7, medium is 4 out of 7, and high is 7 out of 7. We're doing 3 trials and an average, and we've remembered our title.
We're going to give each trial 1 minute and 30 seconds or 90 seconds to see if the glass will shatter.
And lastly, some protective headgear.
Here, today, now, we're actually going to start the experiment. For our first trial and our first independent variable, we're going to try and shatter the glass at a low volume, 2 out of 7. Now, we're going to set the volume to 2 out of 7, pretty low. Get your headgear on. Oh well for that trial, but we still have to try 2 more times, and then we'll go up to more volume. It's time for trial 2. We're going to try everything the same, and just again. So, let's see if it works. Oh well, I guess that didn't work.
Alright, it looks like it's time for the last chance for the lowest volume to make the glass shatter. Alright, I guess that trial didn't work. But here are the results. For trial 1, no sign of any shattering. Same for trial 2 and for trial 3. So we don't really have an average. But it's time to turn up the volume. We're going to make it 4/7, which is a little louder. We call it medium. Here we go. The time will be the same. Same with the glass, same with the tone. I can't believe it. It hasn't worked yet. But it's time for trial 2 of 4 out of 7 medium. Here we go. Guess that didn't work either. Time for the next one.
Okay, now it's time for the final trial of the medium volume, 4 out of 7. 7 being the highest, 0 being the lowest. Get ready. Oh well, that one didn't work either. Well, that was the end of the medium volume trials. Unfortunately, trial 1, no glass shattered. Trial 2, no again. Trial 3, nope. And our average, unfortunately, is none. Now, we're getting ready for full volume. Cover your ears.
The glass isn't broken yet, but with 7 out of 7 in volume, it could. It's time to test if the glass will shatter. Here we go! Even at the highest volume, didn't shatter.
Now, we're going to try it 2 more times. Same volume, same amplifier, same distance, and same amount of time, with the same resonant frequency. Now, see you in about 90 seconds. Oh well, I guess that didn't work either, but we still got one more chance. We're gonna try same volume, 7.7, loudest ever. Same distance, same surface, same time, and same resonant frequency. Get ready. In the low volume, in trials 1, 2, and 3, no glasses broke. In the medium volume, in trials 1, 2, and 3, no glasses broke. In the high volume, in trials 1, 2, and 3, no glasses broke again. So, in all, we had 0 glasses shattered.
Can you believe the results of the experiment?
We were so surprised.
I know, right?
I mean, it was the exact opposite of our hypothesis.
The opposite.
Our hypothesis said that we thought when we got the right resonant frequency at the right volume,
The glass would shatter.
I know, but it didn't even, begin to. We got the right pitch, and we tried tons of different volumes, but still, nothing shattered.
Nothing ever shattered.
In every single trial, the low, medium, and the high, we failed to shatter the glass.
So I guess this can only mean one thing.
This myth is plausible. Plausible. None of the glasses shattered. According to research, the glasses might have had a better chance of shattering if we had had a louder volume and thinner and finer glasses, which makes our myth plausible. Mythbusters!
Something strange in your neighborhood. Who you gonna call?